Hi, we are Eagles. My name's Matthew Voynovich. I am the AI engineer.
My name is Ameya. I work as a backend engineer.
I'm Swaroop. I was the front end engineer.
I'm Matthew McCall, and I'm the hardware engineer.
So, Eagles is a platform that's designed to try and detect gases and other hazards early before, um, because they're hard to see and they're invisible. So, I will get into the dangers.
Yeah. So gas leaks like CO2 and methane are invisible killers. You can't see them, you can't smell them. And right now, even when detectors are networked, that data lives in its own silo. When an alarm sounds, there's no connection to the known environmental hazards already documented by the state. Workers and officials are making decisions with half the picture. What we're building changes that. Our system connects a portable Arduino Nicholas Sensei Me gas sensor to a real-time dashboard that maps uh, live readings directly alongside New York State's environmental uh, rem- remedia- remediation database. So when a sensor triggers at a job site, you're not just seeing them or seeing an alarm, you're seeing it in the context of known contamination sites, site classifications, and historical hazard data. We're breaking down those data silos and giving workers and officials a unified picture they've never had before.
So, I'll get into a quick breakdown of our technologies we used for code generation, Claude Code, Copilot, Gemini, etc. We use Next.js, Supabase, React Native. For data, we took from data.newyork.gov, specifically the remediation sites, and for hardware, we use the Nicholas Sense ME. So our our plan was to have edge sensing with the Nicholas Sense ME and have, when it detected data, push it to your mobile phone to give an alert. It will have GPS that sends it then to our backend. The backend would then aggregate with the New York State data to verify and connect it to a specific remediation site. And then that dashboard would also contain more information on said sites.
So currently, we're using open data to show different parts in the New York State and saying like where specific locations are exposed to like different types of gases. And we hope to also leverage this data to train our own model, such that like we can go in person, kind of like manually test this as well to like keep our data even more up to date. And in the future, we're hoping to have real time data that can like train our model through our website itself.
So I'll move on to a little bit of a demo. This is an example view of our dashboard, but let me. So here is, we were unable to connect everything fully, but here's what our test data looks like from the open data. We have a regular pinning. We have a heat map for everything. If we scrolled out, you'd see it gets stronger, and we cluster all the points. I will move on to our hardware.
Yep. So,
Do you want to alt tab to the nice viewing?
do you want to do this one?
So this is our original, or this is the finalized front end that we plan to integrate everything into. It was a bit of a challenge with all the hardware and the data as we were split up very strictly. Um, it has all the same information, but with dummy data instead, and it would have more stats than the other actual algorithms we showed you. And we'll get to the hardware now.
Yeah. So in addition to the open data, what we also like to do is we have an Arduino with a air sensor. So as you can see right now for gas one, this is measuring regular air. If I now stick it into this jar of CO2 and give it a couple of seconds, what we'll see is that it will actually, as you can see, our confidence for carbon dioxide increases and our confidence for air decreases. So we plan to combine this data as long as with the open data in order to help better inform work sites of potential gaseous hazards. Thank you.